Okay. All right, I'm going to go ahead and get started here. Hopefully, at some point we've got a screen working here. What's this thing showing on the bottom? Shows a red light. That's there. I've already started recording here. Okay. Oh, okay. Now, all right. Now we've got pictures up there. Okay. On Tuesday, everyone we went through and we were able to do the first lab, right? You were able to actually see. You know, you got the. I know I left right after we went through that there, but what I'm going to get sidetracked a little bit today, and I'm going to talk about basically hierarchical design techniques. And the slides alluded to it, but it really didn't go into much detail. Next Tuesday, we'll meet in the lab, and we'll be doing a lab. I'll have a handout. Actually, I'm going to reuse a lab that I wrote for a previous course when I taught this class before. Unfortunately, it's not on this computer, so I can't use it. So I'm going to have to do it from memory here, which is okay, right there. And what we're basically going to do here, and we'll talk a little bit about it. I'm not going to get into great detail today, but what we're going to look at is something called hierarchical design, which basically means we're going to design our system in subsystems. So if we want to do for example, a 8-bit adder, we could do that by doing two 4-bit adders, right? If we want to do a 4-bit adder, we could do that with 4 1-bit adders, right there, right? Correct? So if we look at, and I'm going to pull up the book simply because I don't want to, and hopefully I have my digital book here somewhere. Desktop, digital class, and somewhere, here's our Tochi book, right here. Oh, that's not the right thing, that's just slides for chapter 3. And maybe the circuit I want is in here anyway. Right here. Barry notes, sorry, he doesn't have the circuit. Right here, I was looking for the adder circuit right there, so I didn't have to do it off the top of my head, but Boolean expressions, all right, chapter 4 slide. Right here. And then toward the end of this right here, we get into okay. Hopefully we've got up down. And maybe I'm not going to find it off the top of my head. Right here. I was hoping that we had it here, but there. And I'm trying to cheat here and pull up the circuit without having to enable, disable. There. Yep. Exclusive OR, because the exclusive OR is usually used. Nope. Right there. All right, let's pull up the book itself. Right there. And try to, hopefully he's got somewhere in here the simple adding circuit. Right there, interfacing with the analog world. And no, I am not reading that fast. I'm looking for something in particular. Normally I have the assignment in front of me so that I don't have to draw the circuit off from memory, but if need be, we'll come up with a circuit. And Gates E. Morgan's or Gates. Classic. That's what I get for going to a workshop before class and not having everything with me. Pressure flow. Intermediate signals, no HDL. Some spores. And yep. Okay. All right. We're just going to have to wing it here. So that's perfectly fine. Let me just go through here. And let's just look at a half adder. Half adder has two inputs into it, right? A and B. Right there. And it's going to have two outputs. The sum and the carry out. I'm going to just call it C out for carry out. This is a half adder. So we're just going to look at this. 0, 0, our sum is 0, our carry out is 0. 0, 1, our sum is 1, our carry out is 0. 1, 0, our sum is 1, our carry out is 0. 1, 1, our sum is 0, our carry out is 1. Right there. Now, as it turns out, this circuit is probably simplest defined by using an XOR gate. Right there. And an AND gate. So this circuit is going to look like this. A, B, we have an XOR. A and B go into it. And this is our sum. Out, we have an AND gate, and A and B go into it. And this is our carry out. Right there. So this is our half adder right here. The half adder means that we don't have a carry in. Now the circuit is a little bit more complicated when we want to look at a full adder. A half adder means we're just going to add A and B. A plus B, if it's 0, 0, the output is 0. If it's 1, 0, the output is 1. If it's 0, 1, the output is 1. Our carry out is true only if both inputs are high. So that's how we're going to add two numbers right there. We're going to add two numbers. Now we need another circuit with this. And I was actually trying to find this circuit so I didn't have to sit down and come up with it off the top of my head here. But let's look at the full adder. The full adder is a little bit more difficult. Adder, right here. And we could do this the hard way. And the hard way is we've got three inputs, A, B, and carry in. Those are our three inputs right there. So Let's do the sum out first. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Right here. 1, 0, 1, 1, 1, 0. Did I skip one there? Okay, hold on here. What did I do? 0, 1, 1. All right, that's fine. 1, 0, 0, 1, 0, 0, 1, 0, 1. Is that right? 1, 2, 3, 4, 5, 6, 7. I got one too many here already because 1, 1, 1. Did I do that right? Yeah, okay. I'm hearing comments like there's something wrong here, and I'm thinking that I'm messing up right there. So we have two outputs. One is going to be the stuff right there. Now, the easiest way to look at this is our sum is going to be true if we have one input or three inputs that are high. That's there. 0 plus 0 plus 0 is going to give me a 0 right there. And I'm going to go ahead and put the carry out here, right there. So we have a carry out of 0. 0 plus 0 plus 1 is going to be 1 with no carry out. Right there. 1 plus 0 plus 1 plus 0 is going to be a 1 with no carry out. 0 plus 1 plus 1 is going to be a 0 with a carry out. Right there. 1 plus 0 is going to be a 1 with no carry out. 1 plus 0 plus 1 is going to be a 0 with a carry out. And let me put lines across here to where we can see these. That's there. 1 plus 1 plus 0 is also going to be a 0 with a carry out. And 1 plus 1 plus 1 is going to be a 1 with a carry out, right there. Now, there are simpler ways of drawing this circuit, but I'm just going to do it brute force just simply because I don't want to go through the time of going through a Karnoff map. We could do a Karnoff map on this and come up with the simplest circuit right there. We would do. Matter of fact, let's just go ahead and do that. That way we can practice our Karnoff map again. Right there. So, as we go through here, right here, zoom out, right here. Let's go ahead and put a Karnoff map here. A naught, B naught, A naught, B, A, B, A, B naught, C naught, C, right? And this is going to be a 0, a 1, and let me go ahead and put my 0, 1, 2, 3, 4, 5, 6, 7. So my next one here is going to be a 1, right? A 0. Then we jump down to here. And this is 1, 0, 1, 2, 3, 4, 5, 6, 7. So 4 is going to be a 1. 5 is a 0. 6 is a 0. And 7 is a 1, right? Now, as we look at this here, it doesn't look like we're going to simplify it at all, right? You know, in other words, are no groups of 2 here. This is now, if we use XORs, we can come up with a simplest circuit, but it looks like our simplest circuit using just sum of products notation is going to be flat out A naught, B naught, C plus A, B naught, C plus A, B, C naught plus A, B naught, C naught right there. That looks like our simplest notation there, right? So we'll use that. Get there. Our carry out right there. And I'm just going to circle the ones here. There's a 1 here, a 1 here, 1 here, 1 here. That looks like it's going to be a little bit simpler right there. Let's just go ahead and do our carry out right here, right there. So again, we're going to just go 0, 0, 0, 1. We jump down to here to 1, 1. Excuse me here. What did I do there? I messed that up. 0, 0, 0, 1, 0, 1, 1, 1, right there, right? Does that work there? Everyone go through the 0, 0. This is 0, 1, 2, 3, 4, or excuse me, 6, 7, 4, 5. There are 6, 7, and 5 are all ones. The 3 is a 1. Right there. Does that look right? Help me out here. That 3 is a 1. 5 is a 1. Excuse me. 3 is a 1. 4 is a 0. 5 is a 1. 6 is a 1. 7 is a 1. So as we go through and we look at that right there, it looks like we've got a group of 2 here, a group of 2 here, and a group of 2 here. 3 groups of 2. Is that looks about the simplest right there? So the first group of 2 is going to be this group of 2 right here is going to be BC. BC plus, this is AB plus, and this last group of 2 looks like it's AC. Right there. Does that look right? We'll find out whether it's right or not because we're going to simulate this. Right? This group of 2, going from here to here, the A changes, so that drops out, so that's BC. This group from here to here is AB. And this group from here to here, the B changes, so it's AC. Right there. So those are our 3 groups of 2. So these are our 2 functions right here. This is equal to our carry out. This is equal to our sum right there. So we're going to keep those in mind. Hopefully somebody will write them down. I need to start bringing a whiteboard marker so I can write this here, that there. But we can go back and forth between the 2 of these. So let's go ahead and start going through. I'm going to come back to this here. But what I'm going to do is a 4-bit adder. And the way I'm going to do a 4-bit adder is that I've got a half adder right here that I'm going to draw. I'm going to design this half adder. Inside this half adder is going to be, and where were we? It's going to be this circuit right here. This circuit right here. This is our half adder circuit right there. It's got 2 inputs and 2 outputs. So we're going to draw that. Our next circuit is we're going to draw a full adder right there. And wherever I'm at on my pages here, I need to, all right, here we go. Yeah, maybe. Okay, how do I get to my next page here? View. Do. Share. Page. Okay. Well, I'll just stay on the same page since this thing's wanting to give me trouble. So I'm going to have a half adder right there. And into my half adder, I'm going to have, and I'm going to call it A0 and B0. And the reason is I'm adding 2 numbers. And I want to add A3.0 to B3.0. and you end up with the result, the sum of those two. So we're going to add those two up there. The output of this is going to be, and I probably did this kind of backwards, but let me change this here, this drawing here. I'm going to put half adder inside here. And going into this here is A0, B0. Coming out of this is my sum 0, and then going into my next full adder, this is a full adder, we're going to have, here's our carry out from here, goes into the carry, this is carry out, this is the carry in. And then we go A1, B1. Coming out of this is also our sum, that's 1, and going into our next one here. B2 or A2, B2, and coming out of this here is our sum 2, and this is our carry into our next one right here. A3, B3, and coming out of this is our carry out, and coming out of this is S3, 3 here. This is S2 right here. So what we're going to be doing is we're designing a 4-bit adder by using one half adder and 3 full adders. Now, we could just do a full adder and just simply ground the carry in into it. And that might be the easiest way to do it right there. You know, and we'll get the same result. It really doesn't matter. So what we need to do is we need to look at this circuit right here for the half adder and just go ahead and design this. Now, you're going to do this in the lab, and I've got some pretty detailed instructions for you to follow. But I'm going to go through this here. The instructions are going to be a little bit different because I'm going to have the circuit for the full adder is actually simpler because it's one that's been optimized using exclusive orders right there. So, well, let's just go through and do the half adder right here. So I'm going to go ahead and I'm just going to create a new project. Now this is where the software gets very, very tricky at times. And you're going to, as I go through this, you're going to find that I have to play some games here. And so next Tuesday's lab, and we'll be meeting in the lab up there next Tuesday. That's there. We'll go through this right here. We're going to create a new project here, and I'm going to go ahead and put it, and I'm going to call this new project here, and I'm going to call this 4 adder 4-bit right there. Right there. File name, and open that right there. That's our directory. And I'm going to call this adder 4-bit. Right there. And since the last time I used it, I used our board, I don't have to change anything right there. So I'm just going to say use project settings up there, or use existing project settings. Maybe I don't have. And I'm sorry, folks, but as we recall from the other day, that I got to unplug this thing in order to see enough of the screen. This will not let me. All right, settings. Okay. Sorry about that, but unless I can go buy better projectors, I'm stuck having to do that from time to time. So, all right, Now let's here's what we're going to do is we're going to go ahead and draw our half adder right there, and I may have to go back and forth between the two screens in order to see what's going on there. But when we draw our full adder, we're going to go ahead and we're going to create a new file, and this is going to be a block schematic right there. And we've got an XOR and an AND gate. That one I can remember off the top of my head. So this is an XOR right there. And here's our AND 2 right there. Input. And I'm going to put 2 inputs in. And 2 outputs. I'm just going to call them A and B here for now. We'll change those names later. Carry right there. Okay, there's our basic circuit now. This is where things get a lot different and a lot more difficult than last week. Right there. Is because we're now going to save this file, save as, and I'm going to call it half adder right there. Notice that it's wanted to default to the name of the top level, so we're going to say half adder right there. And then we're going to, at this point, we're going to create a symbol for this file right there. So we created a symbol for this file right there so that we can use it in other drawings. Now, if I want to test this, then I have to go through, and it's a little bit tricky, but what we can do is we can go through and we can make this the top level, test it, and make sure it works. And I'm going to go through and do that. But as you do this in the lab next week, you'll find it's a little tricky. So what we're going to do is we're going to set this to the top level entity. And the reason we do that is that it tells the compiler that treat this as our top level right there. And we're going to get the same warnings as we did last time, right there. Right there. Okay. Now I'm going to go through and I'm going to simulate it. Open or new. A vector waveform file. And we're going to go through and change our edit. Again, this is something you just do all the time. That's there, you just get the habit of doing it. $50. Group. Count. Right there. We can see there's our inputs right there. And we're going to go ahead and save this. And now what's going to happen is I'm going to save this, and I'm going to have to delete it later. And the problem is because I want to test each level that there, and I don't want to create a project for each level, so I'm just going through that there. So I hit save, and then I should be able to just simulate this right there. And we should see what we should expect to see right there. The only time our carry out is high is when they're both high. Our sum is high when only one or the other is high. Now we see some glitches in here which you would never see if you're flipping switches, because those are happening at like 2 or 3 nanoseconds. You know, if you're fast enough where you can see that light come on in 2 or 3, in that fraction of, you know, less than 6 or 7 nanoseconds, your eyes are much better than the average human, right? Right there. Okay, so we did our half adder. So we're done with the half adder. We're going to close this out, and we're now going to do the full adder. Now the full adder was much more complicated, as we recall, right? It required 2 circuits. That's there. And we're going to draw them on the same page that's there. Right there. So as we go through, and we're going to create our block schematic right there. And when we look at our full adder, right here, I'm going to try, and my screen resolution is 4. I'm going to try to put this on the other half of the screen. And why is this not? Okay, well, we'll see if we can make this work here right there. So as we look at our full adder, we had 3, no, what happened there? This is our circuit we had right here, right there. A naught, B dot C, A, B dot C, A, B, C dot, like that right here. So I'm just going to go through and I'm just going to create a PLC type structure where I'm going to bring in A, B, C, and I'm just going to draw the line down so I can connect to them right there. So I need 4 3-input AND gates right there, and we're going to connect each of those, and we'll do the carry out separately. Again, that'll be on the same page up there. So let's just go through here. Let's put 4 inputs in here. Input. Then I'm going to do them 1, 2, 3, 4 right here. And I'm going to draw a line down like this one right here. I'm going to draw a line here. We may have to move this one out a little bit here, because what I want to do is I want to put a knot in here, and I want to rotate that. Let's hold on here. And rotate by, see, the reason I did that, as you can see, is I'm wanting to connect it up there, because this now becomes my A naught line right here. Right here. This becomes my B naught line. Right there. And we keep doing this here. This now becomes our C naught line. And we have to Give ourselves a little bit more room here. Now, actually, I don't have to do this. There's a easier way of doing this, to be honest with you. But that's there. And the reason is I can name these nodes. In other words, let me go through and make our drawing a little bit simpler since we're trying to simplify this. Let's go ahead and name our pin right here. That's A, B, C, D. And what I'm going to do is I'm going to leave this circuit here, and I'm going to go elsewhere, but I'm going to name this. I'm going to delete this one right here. And let me just name this. I should be able to just. Yeah, why is it not letting me name it? Oh, okay, yep. All right. All I do is I highlight this, and I just say A right there. So that is now A. I click on this, and I call this A not right there. I click on this one here. I call this B. I click on this one here, and I call this B not right there. I click on this one here. I call it C. I click on this one here and call it C not. Click on this one here and call it D. And click on this one and call it D not. D not, right there. So what I've done is I've named these nets or nodes right there. So I don't have to physically connect them up to my 4 AND gate right there. I just say what those 4 inputs are right there. So let me shrink this down here a little bit and go over here, right here, and we'll make it a little larger here. And elsewhere in the circuit, we're just going to simply put in right here. Let's just go ahead and put in a 4 input AND gate, right there. Excuse me, a 3 input AND gate. I'm going to go back and look at my equation here. I need 4 3 input AND gates, right? So I need an AND 3. Now I'm just going to draw one of these for now. And the reason I'm going to draw one of them for now is because I want to copy and paste here. Right here. All right. For right now, let me just look at this right here. Here's my 3 input AND gate. My first equation is A naught, B naught, A naught, B naught, C, right? So I'm just going to click on this, and I'm going to say A naught. This one is B naught. B naught. And this one here is C, right? Right there. A naught, B naught, C. So what I'm going to do now is I'm going to copy that, edit, copy. and paste it here. Right there. And I'm going to edit these right here. Make sure this, yeah. Undo. Unfortunately, the drawing here is a little funky here, but this A dot right here, if we look at my next equation, it's supposed to be A B naught C, right? So we just change this to an A, B naught, and C. Was that C naught was the last one? No, it's A B naught right there. That doesn't make sense. A B naught. I think I got a mistake here. That doesn't look right. And the reason that does not look right is that I've got, as I look at my sum, A, B naught, I think I made a mistake here. At there, because this is A, B naught, C. That should be a 0 on my carry out right there. That's not right. That is not right. I made a mistake in coming up with the equations for that there. Because that should definitely be wrong. Why didn't someone catch me that there? Because as we go back and we look at this here, let's go back and re-look at our design, because I definitely made a mistake here. Right there. Because as we look at this right here, A naught, A0000, that is definitely a 0. This is a 1. A, B, C naught is a 0, right? Or no, 1, excuse me. Is a 1. This is a 0. The next one is A, B, C. This should be a 1 here for 4. Yeah, 4 should be a 1 here, right there. 5 should be a 0, right there. 6 should be a 0, and 7 should be a 1. All right, that looks like what I had, didn't it? Evidently, I wrote this down wrong, because this should be A dot B C. That's this one here. This should be A, B. All right, here's where my mistake is. This should be A naught, B, C naught, right there. And this should be A, B, C, right here. And this should be A, B naught, C naught. Yep. So evidently, I made a mistake writing that down. Whose job was it to keep track of me today? Who's supposed to watch me and catch my mistakes? That's there. Okay. The good thing I caught it now instead of later. So our half adder's okay. That's there. And I think our full adder, or our carry out looks good. So going back to our circuit here, right here, this should be this should be C naught there. Right there. So this should be B naught. Okay. What is my next one? Let's start over again here. Let's look at that there. First one is A naught, B naught, C. A naught, B naught, C. Next one should be A naught, B, C naught. A naught, B, C naught. A naught, B, C naught. Okay, there we go. That's the next one. Now, let's copy this again. edit, copy, paste. All right, let's go back to the next one. The next one is ABC, right? A, B, C. All right, now our last one. Our last one is A, B naught, C naught. A, B naught, C naught. Okay. All right, now we've got all those done. Let's go ahead and, again, we need to shrink this up because we've run out of room here. Right here, let's go ahead and put in an OR 3 or OR 4. Right here. This mouse is not the best for this kind of work. All right, so there's our circuit here, and this is going to be our output. And oh, I wanted to try to make the sheet size larger, but evidently I can't. Oh, there we go. Okay. And this is our sum. Right there. Okay. Now we've got to repeat this process now with the carry out. Oh, that's a simpler circuit. I'm just going to do the same way down here. Let's make this smaller. Right here. And I'm going to come down to here, and I'm going to, now this circuit is simpler. Right here. Is it's got 2 input AND gates, right? And they're BC, AB, and AC. So that's fairly simple. And it's a 3 there. So let's just go through and put that in. So we need to have a AND 2 right here. And I'm just going to do the same way as I did last time. I'm going to do 1, and then I'm going to copy it. Right here. So let's go ahead and put in our net here. Right here. And the first one was what? AB? B? Right there. We'll copy that one. And this next one was what, AC? And then the last one was BC, right? And I'm going to cheat here. I'm just going to put CB right there. And then we go ahead and we put in a OR2 or OR3. This keyboard is not very good for a mouse pad. Okay, and then we need an output over here, right? For our carry out. See. Okay. That is an ugly drawing, right? It took a good hour almost to draw that. So we may be finishing this. We'll get through this here, right here. So at this point, we're going to go through and we're going to, again, save this. File, save as. And this time we're going to call it a full adder, right there. And we're going to go ahead and create a default symbol for it, right there. So now I've created the default symbol. So now we're going to go through and we're going to simulate this thing again and see how it works, right there. So again, we're going to change this here to where it says set as top entity. It's not really the top entity. The top entity is later, but we're just doing this temporarily. Then we're going to go ahead and we're going to open our vector waveform file right here. And we're going to delete everything. The reason we're going to delete everything is because we're changing the project that we're wanting to symbolize. So let's go through here and node finder. Oh, before I do that, cancel. I need to compile it. I forgot to compile it. You can't do anything until you compile because the node finder won't find the nodes. Oh, we got errors. Illegal wire or bus date right there. Okay, what this is telling me is that, all right, what this is telling me is when I named that, I called it C not. I have a space here, C not, right there. That's there. So, and again, we're looking at we have multiple. It's in 13, it's missing source signal. N1, N2. All right, evidently, hold on here a second. One of these. Okay. this didn't copy over the, whenever they're green like that, that tells me that they're not connected to the node. Is there any other greens? All right, let's. Oh, warning, pin D not connected. You know what? I had 4 inputs. I only supposed to have 3 inputs. So I put pin D in there and put that not inverter there, and then I didn't use it, so it'll take it out for me. Yeah, that was just something stupid on my part. If you go back to right here, see, I put pin D there, and I don't need it. So let's just go ahead and delete it. Right there. That's there. I don't know why. I'm just so much in the habit of doing 4 input systems that I put a pin D in there. And you'll need every bit of 2 hours on Monday or Tuesday, I think, to do this. Okay. Now we're going to go through here and let's see. Now, of course, it's showing my shows my correct pins. Okay. And then we can save this and then run the simulation again. And I'm not going to go through the simulation. I'm going to assume it's right. That's a dangerous assumption to make. You can't make that when you write your lab report. You have to go through and make sure that when I add 0, 0, 0, 0, add these 3 up, that's correct. It's here the carry, that my sum is out, that there, you ignore these glitches, but you would go through and you would check this all the way through and make sure that it does do the job of a full adder. Now here comes the interesting part. We're going to put everything together. And we're going to create a new file here. And now when I add a new part, under project, I have 2 little blocks here called half adder and full adder. Right there. So if we take our half adder, right there it is. Double click. Right here. You see, there, and then I will take this here. And you know what I did? these were supposed to be full adders. Full adders, yeah. And guess what, my friend? I messed up here. And the reason is that I got to go back and reopen the file. My full adder. I don't want the symbol. I want the schematic file is what I want. Okay. What had happened was my full adder, remember the first time I put D in there? And I said I didn't need D, but I created the symbol with D in there, so I had to go back and recreate the symbol right there. So this is my symbol for my full adder right there, and I could just go through here and I could add 3 of these in here right there. And then I would then go through and connect. I'm not going to go through and finish it right there. Now, one of the things I should point out is that this has got a little bit of a funky issue right here, is if I draw this, it's going to be ugly. And the reason it's going to be ugly is that my carry in here, first off, it's got a bad name. I probably should call it carry in instead of C right there. So I probably should go back and clean that up. And the other thing is I probably would want to open, and I would want to open, or not new, open. And I want to open my symbol file here, and I can move this pin to the top here. That would make it easier to, see, I can move my pins around however I want to make it simpler. And the reason I would do that is, let me save that. Right there. I don't know why it saved it. So. Right there. Now if I edit selected symbol, yeah, see, it's selected right there. See, now when I want to connect between here and here, I can put it to the top there. And you see, I don't have to cross the wires when you're that there. It makes it a little easier to draw. So as your projects get larger, you start thinking about things like that. And actually what you could do is I could edit this symbol here and bring the carry out on the bottom and just connect it like that right there. So I think I'm going to stop at this point. We've got a lot more to do to finish this project out there. I'm going to go through, and on Tuesday you'll start drawing some of this. The handout that I have will have a much simpler drawing for the full carry. There's a much simpler circuit. I just didn't bring it with me, and I didn't look for it there, so I did it from scratch. You can always do it from scratch. It doesn't affect the overall design because the software compresses it into the smallest circuit it needs to be anyway. So whether you go through a lot of work, but you'll work with the simpler drawing there. But as you can see, the whole idea is that we don't regurgitate each one of these. Now, if I double-click onto this, that will open up that circuit. So this is actually going to generate 4 copies of that circuit in the final circuit when it's all said and done. But we only have to draw it once. And that's the whole idea of hierarchical design, is that there. And even if we're only going to use it one time, you still would want to look at it from the idea of a block diagram. You design each sub-circuit separately, test it, and then you bring it in together as a full circuit right there. So with that said, I probably talked longer than I probably, an hour and 5 minutes. That's not terribly bad. Going through this kind of work actually an hour is a long time. I know it's pretty boring for you, right? So, well, like I said, Tuesday you get to do it. That's there. And you'll find that that hour will go by pretty quick. That's there. So, all right, with that said, I will see everyone Tuesday upstairs, 4th floor, okay? And I'm going to go upstairs and reserve the room for Tuesday.